Well, hello everyone, and welcome back to Adrian's Digital Basement. Now, it's true that the very first thing I ever owned that had a microprocessor in it was the Commodore VIC-20. I got this computer in 1982 when I was around 7 years old. I had an absolute blast with this thing, learning BASIC, playing games, writing my own programs, and storing them on the little Commodore data set. The VIC-20 started me off on my career and pretty much brought me to where I am today, making these videos about retro computers. But as an offshoot to all the computers and the love that I have for them, I also have a love for a very specific game console. And it's this one right here, which I managed to get my hands on around 1986. Now, it had already been out for a couple years in the US, but all my friends were getting them. And of course, I'd go over to their houses and start playing on the console and realize that, well, compared to my Apple IIc, the games on the Nintendo were just miles ahead. It's really one of the reasons why I absolutely love the Nintendo gamepad here. And even though this thing is boxy and kind of digs into your hand a little bit compared to modern stuff, I feel that, well, at the time in the 80s when this came out, this was pretty revolutionary as just being such an amazing controller that just worked so well. And compared to the analog sticks I was using on my Apple II, it really just kind of blew them away. When this machine was contemporary, I love the fact that it had easy audio-video connections on the side here that allowed you to plug it into your TV and bypass the RF modulator, just giving you better picture quality. But one of the things about the NES is that it's only composite video. The actual graphics chip that's inside of here, called the PPU, generates a composite signal internally, so there's really no easy way to get anything better out of this, like S-Video component or, of course, RGB. The original Nintendo Family computer, which essentially is exactly the same on the insides as the NES, actually was one step worse in that it only had RF outputs. Now, this one that's been donated by a viewer has been modified to have AV outputs, and it deleted the RF output entirely. But one of the issues with the Famicom is that it has quite a lot of jail bars in the video output due to the way the PCB is laid out in this particular console. The other thing about this is pretty funny is it has these very short little cables. So if you're looking for good video quality, these early Famicoms are not the way to go. And for the original NES, you're stuck with composite video, which looks okay, but you get all the usual NTSC dots all around all colors. So what I want to look at today is a modern recreation of the Nintendo and the Famicom that uses original chips, so it's 100% compatible, at least I think it is, but it offers improved video output, including S-Video and RGB. And it does it all for a really reasonable price as well. So without further ado, let's get right to it. So with the original NES and the Famicom, for a while now you've been able to get an add-on board that goes under the PPU, or the picture processing unit in here, that will intercept the signals that go from the CPU, well, and the rest of the console to the PPU, and then using an FPGA can reconstruct an RGB image, which after you've modded your console to add an RGB jack somewhere on here, you can actually get pixel perfect RGB output out of this console that normally only supports composite video. I know a lot of the speedrunners and folks who do a lot of Let's Play stuff on Twitch and YouTube have those mods done to their NES to get the best possible picture quality, and they need to play on real hardware, not emulation or not entire FPGA consoles, because if you're doing speedrunning and stuff like that, you need to make sure you have the original motherboard and all the original components in here so that obviously the timing is not off and stuff like that. The thing about the particular upgrade, which works on the NES and the original Famicom, is that it's pretty expensive. I think it's about $130 before shipping, so by the time you get it shipped to somewhere like the US, it's kind of costly. And because of that, I always sort of precluded myself from buying it, even though I knew, based on reviews I'd seen on other YouTube channels, that it offered really, really good picture quality. So I was talking with Mark over the Retro channel about the fact that soon there's hopefully going to be an NTSC version of the Copper Dragon or the Lumico device that would go under the PPU on this and do that same conversion to pixel perfect display, but then output it over something, say, like just the RF jack right here as composite video to a device like the RGB to HDMI, which would decode the pixel perfect display externally. There's already a PAL version of that device, and I'm pretty sure an NTSC version is being worked on. It's just not available quite yet. So in the meantime, I started browsing on AliExpress, just looking around to see what's on there, as I do. And I stumbled across this thing here called the RGB Famicom NES RGB Lava RGB Kit 1.2, supports Famicom, NES, whatever, a bunch of stuff for $37.83 plus $9 shipping or thereabouts. And what this seems to be is basically a clone of that more expensive NES RGB device, but we can see that it's installed on the NES board there. And just like all the other video output improvement devices for the NES and the Famicom, you have to remove the PPU and put this board between the PPU and the motherboard. So the PPU is still generating all the graphics. It's just that this board here will have some kind of an FPGA on it, and that looks like the Famicom there, that will, I guess, reconstruct the graphics in its own buffer and then output that via RGB. I looked around to see if there's any reviews for this card, and I did find one. It seems that it's relatively new and not a lot of people have at least reviewed it on the internet. And what's interesting is it does seem like the company who makes this actually publishes the Gerber files and I guess whatever you need to program the FPGA, so you can technically make your own. And the one review that I found, which I can't remember the link to now, it was sort of a live stream where someone built up their own using a PCB they had made at PCBWay, and then they installed it in the NES and it actually worked. So I have to admit, this board here intrigued me. But on the other hand, I didn't love the whole idea about having to modify my console and drilling a hole or altering it inside by changing the RF modulator to support RGB, which seems like you have to do to really get a module like this or the original NES RGB installed in your console. I ended up finding the original website for this product. And looking at the website a little further, it seems they have entire replacement motherboards that have this FPGA stuff integrated into it. And this seems to be it right here. Let's see if we can get a larger picture of it. There it is. So there's that whole RGB FPGA thing. Now this motherboard appears to be a direct replica of the original NES or Famicom using the original NES chips here. But then they've modified it a little bit to have extra video output ports, this FPGA for the video conversion. And then of course it has controller ports, which is not normal. No Famicoms have that, I don't think. And the 15-pin port. And it looks like it has an SD card slot as well. And you can see right here in the description, even without doing Google Translate, this has AV output, S-Video, RGB-S, which is sync, and HDMI of all things. That's even better than this little board, which I am pretty sure only has RGB and maybe S-Video and potentially composite. Well, scrolling down a little bit further seems to be a different version of a replacement motherboard. And this one has RGB-S, so RGB plus sync, S-Video, AV, but it lacks the HDMI, which is totally fine to be honest, because with RGB you could just plug it into a scan converter and then you could get HDMI that way. And I don't exactly know the difference between these two, but this one seems to be potentially a little bit newer. Look at the date here, it says August 19th, and this one is November 22nd. So there's some pretty new firmware here, 1.5 that has just come out. And if we take a look at this motherboard in close-up, we can see it has the original PPU and CPU installed in sockets. And incidentally, it's the CPU on the NES that generates all the sound, and the PPU is handling the graphics. There are all sorts of questions about the FPGA conversion that's happening here. Does it introduce lag? Because obviously the composite video that's coming right out of the PPU has no lag. And you think that conversion might introduce lag, and even 1 frame of lag at the 60 frames per second that NTSC runs at is 16.6 milliseconds, which can be pretty significant for people who need that instant response time for speed running and stuff like that. So back on their website, scrolling down, there's this RSC Lite. And it looks like the only main difference, besides the fact that this is like a render as opposed to like a photograph, this has an SD card there and this one does not. So I don't know what else the difference is, like if the FPGA is different or not. Let's see if we can kind of see a difference between these two. This has an extra, what looks like a STM microcontroller there, which perhaps is there to support the SD card. There's a couple other components that look different. That one there is not there. So looking at this website, I thought it'd be kind of cool to have one of these replica consoles here, you know, with the original chips, but the higher quality video output. But without a case and stuff, I don't know, it doesn't really seem appealing to me. Well, then I went back to AliExpress and I typed in Lava RSC and take a look at this. Not only do they sell the motherboards for $130, but for mere dollars more, they actually sell a version with a full case. And they also have the light version in a case for $103. Now, looking through the little photos on this listing, it's clearly the same exact motherboard with that STM microcontroller up here and the SD card slot. And we can see on the back, it looks like it's using a Sega Genesis RGB out connector. We have AV, which is stereo, even though the NES is mono. We have a 3.5mm headphone jack, and it looks like a DC barrel jack input. Now, what's interesting is it does mention that it has S-Video output, but I don't see an S-Video jack on here. So I kind of question that. I don't really know how that works. I guess the possibility is it's using the headphone jack with YC output. So you just use a stereo jack and then you have two RCA jacks, and that is the S-Video. Now, here's what's funny is I was just saying how I thought that the price of the NES RGB was a little bit too expensive for me. But now I'm really tempted by this $135 console here from AliExpress, which is basically the same price. So what am I doing here? Well, I think it goes back to what I was saying before, is the NES RGB or that clone RGB adapter that these Lava folks sell requires modification of your NES, which on the American ones typically involves removing the RF modulator power supply thing in here. So you have to get a whole extra module to do that so that you could convert the jack here from the RCA jack for RF output over to use, I think, the Sega Genesis multi-pin connector, just like this thing is using. So more modifications are necessary, and that means having to buy those extra mods. So there's even additional expense over that. But this thing, on the other hand, means that I don't have to make any mods to my original consoles whatsoever. I can leave them just as is. And theoretically, this thing should work just as well as these, but then offer that improved video quality. So I went ahead and pulled the trigger, and I actually did it on Singles Day. So there was a bunch of coupons and some sales, and here it is. I got the console, and I got it for $131 shipped. So I thought that was potentially a really good deal for this little clone console here, and I figured let's test this thing out. Let's give it a review and see how well it actually works. So as you can tell, I chose the version that has the Famicom kind of dark red colors here, but also the clear case. I wanted it to look a little bit different. And it came in a nondescript box with basically just a little 9-volt power supply, and that's it. Now let's compare this to the size of the original Nintendo Famicom. And as you can see, it's significantly smaller. Obviously, it doesn't have these integrated controllers here, and even though it has little indentations in here, it doesn't actually fit or anything like that. I think that's just a little bit of a stylistic thing. Otherwise, it's a very good, faithful imitation. Unlike the Famicom, which has this eject slider here, this thing actually has a button here, which when we look at the writing on here, it seems to say settings right there. So this is actually a button to push, that's settings. We have a toggle switch for on off as opposed to a slider on the Famicom, and then a reset button, which is the same on both of them. There are the two regular NES controller ports. This does have a 15-pin connector on here, which should be the same as the 15-pin connector on the front of the Famicom here for plugging in the keyboard or any additional accessories, none of which I actually have. There's that card slot, which is only available on the full version and not the light version. I think what this lets you do is update the firmware on this, well, specifically on the video conversion FPGA, and also you can add customized palettes, color palettes, for the way the conversion happens between the composite video and the RGB output. Looking at the back here, we have AV out, which I assume is the RGB, video, right and left audio, another audio jack, so it's not S-Video like I thought it might be, power in, and that's it. Looking at the bottom here, it's the Lava Retro Famigame System, the Lava RSC, just as we saw there. Lava genuine products provide your best experience. 2024 Lava Studio, made in China. I must say the plastic quality on the case is really good. This thing is very solidly built. It's not creaky or crappy feeling at all. Pretty impressive, to be honest. Now, for those of you in North America, the one thing you do have to consider if you get one of these is that the cartridge connector slot on it is not the same as the one used for the NES. Nintendo, for whatever reason, changed to a larger, bigger cartridge physical size for the US front-loader NESs. Well, not just US, but the ones in Europe and the rest of the world, basically. So the cartridges for this are not compatible with the replica console here. It is, without a doubt, the same exact footprint and connector as the regular Famicom. So here's a Famicom cartridge here, and that goes in no problem there, and it goes in no problem on there as well. I also noticed that the connector they're using in there appears to have gold contacts on it, so that's a good thing. That should help with the corrosion a little bit. And I guess now I'm really concerned about where the S-Video is, because that was one of the things that I was really looking forward to. And unfortunately, I completely forgot to buy the RGB cable that plugs into this for the Sega Genesis Mainly because the Sega Genesis that I have personally has the larger DIN connector because it's one of the first generation ones, and I've never had a Sega Genesis that used this smaller connector. So I think the first thing we need to do is we need to see if this thing even works. So let's start there, and we can just use the AV jacks to do that. So for powering it up, I am just going to use this little cable here. This goes from USB-C, and it outputs 9 volts here. It is using USB-C power delivery, and this is a center positive 9 volt barrel jack here. So we'll just plug this into there like so, and we'll just grab this little power bank right here, and we'll connect it up to the PD jack. And you can see it's already negotiated the 9 volt power delivery output. Even though the console's off right now, it's still delivering 9 volts to the barrel jack to the console, which is perfect. Interesting that it has some power draw even though the console's off. Maybe the console's on, I don't know. Now, one of the things about this console is I'm fully expecting that the CPU and PPU in here are clones, which are made by UMC. They're the most common clone manufacturer, and there are some issues with those chips when it comes to compatibility, specifically around the way the sound is generated. Luckily, I have spare NES boards that I was given after I think the consoles were scrapped, probably because they weren't working due to people thinking they had bad cartridge connectors. And I can obviously just take these chips right off here, and I've actually already desoldered them. Now, I've tested this previously, so I know this is a working board, because with some deoxit and a cartridge connector here, it's working fine. So if this thing does work, and we open it up and find non-genuine parts, I'm actually just going to swap the CPU and PPU off this board and put them into here, just to bring that full compatibility and fix the sound. So we're hooked up to the RetroTink 5X Pro. We're going to set this back to composite, and let's turn this on. Okay, we're getting a video signal, even though there's no cartridge in here. We're just getting a black screen. Okay, that's kind of what I would expect. So let's try this Galaxian cartridge, an actual original Famicom Japanese cartridge from Namco. Let's pop this in, see what we get. There it freaking is. All right, well, it freaking works. That's exciting. So I didn't waste my money. It's not like I couldn't have tried to file a claim, get my money back if this thing was broken. But it does work. So I have NES controller plugged in. We have working sound. Okay. Okay, I hit pause for a sec here. Let's push this settings button here. Okay, so it is processing the video, obviously. PC10, YUV, FCUX, and NTSC. I mean, the color palette's changing here, but I guess I don't really know how this works. There was zero manual with this thing. I had no instructions whatsoever. I don't know how any of this works. I don't know how the SD card slot works, nothing. And the funny thing is, the NTSC palette is definitely the most muted of all of them, but the red on the NES console is actually quite a muted color. That's just how it is on the real hardware. But we look at PC10, and everything is looking super vibrant, which probably isn't super accurate, but it might be more desirable depending on what you're used to. So the funny thing is here is clearly the AV output is being processed by the FPGA. So from a lag perspective, the only way we can try to ascertain what lag is introduced by the conversion circuitry is probably for me to use the oscilloscope to try to trigger off the pin that is actually the composite output on the main PPU, compare that to the output signal coming out of this using the 2 channels. And that should allow us to see the exact lag that is produced by the conversion process. Now I'm curious, if we turn this on without the cartridge installed, does the button work anymore? No, it doesn't seem to do anything. That's intriguing. So let's plug in this multi-cart here. All right, looks like it's working. Let's start up the game that I have in memory here, which I'm pretty sure is Bomberman 2. Yes, it is. I love this game so much. All right, so I have a save state here. I was playing this just the other day. Oops. It's hard to play through the capture device because I'm looking at this through OBS now, and I'm not looking at it through a direct feed. Ah. Yeah, well, I just killed myself. Ignore my playing here. I'm actually much better. Like I said, the capture device stuff is the problem. All right, let's take a look at Duck Hunt and Mario Brothers, because this is a game that I think everyone is ultimately super familiar with when it comes to the color palette that it uses. So especially Super Mario Brothers here. So let's do the select button here. Okay, well that looks way wrong. The brown there of the ground and the sign is just totally not correct. YUV, definitely a little more like I would be used to. FCEUX, I'm pretty sure this is an emulator color palette from one of the popular emulators, because I always remember it gave a really kind of sky blue color for the sky, but then the ground and the Mario Brothers sign has a lot more red in it than is normal for NTSC. Now I have the audio being captured directly by the computer here, so I have the speakers turned down. I should be wearing headphones because I think my mic is going to pick up the speakers a little bit. But let's try to hear if we can hear the sound being messed up at all. Sounds okay. Because I've heard some of the clone CPUs that have that weird sound thing going on with them. It's like the two of the sound channels are reversed, like the square and the triangle wave or something like that, and it just doesn't quite work right. Anyhow, it seems to be working absolutely fine here. Let me hold down, oh, well that's NTSC by the way. PC10, YUV. YUV seems slightly brighter than NTSC. Obviously YUV would stand for component. But if I hold down the settings button, that doesn't really do anything. So it's not like we get any actual settings here. What if I hold the settings button down and push reset? No, that didn't do anything either. Let's try this game here. This has extra audio. And the thing is, I think my multi-cart here isn't working properly because I don't think we're getting the extra audio. No, there's no extra audio. I think that's a problem with this cartridge. It is not with this console because it's exactly the same on the real Famicom as well. There should be extra audio emulated by the FPGA in the cartridge, and it's not doing it properly. So this is a cheap kind of clone cartridge, and I think that's what's going on here. All right, well, this thing seems to work fine, at least using the AV mode. So why don't we crack this thing open? Let's take a look inside and see what we see, at least from the clone CPU and that side of things. Now, I'm kind of curious if we go download the, I don't know, that zip file that was on their website, I think with newer firmware than maybe this has. I don't even know what version this has because it doesn't tell us or anything. Perhaps there's some documentation there. Maybe it's in Chinese. We can do some Google Translate to see what that actually says. Okay, well, that came apart very easily. All right, we have some more screws in here, but they are just normal Phillips. So interesting, there's a header right there. Must be for programming the FPGA. Not populated though, sorry. There you go, now you can see it there. The construction of the PCB looks good. I don't see a lot of like flux residue or whatnot. Soldering seems fine. Definitely you can see that it is ENG coded here, so it's a high quality PCB. Okay, this is connected somehow. There's a little connector there. Let's get this off. There's the motherboard. First thing is, I just wanted to look at this little back panel here. I think this is a PCB. I love the idea of using a PCB for paneling. You can see how it's cut out of the fiberglass material. That is clever. All right, so here are the two chips that we have on here, and I don't know what the deal is with these. They don't look like clones to me. They seem legit. And our crystal oscillator, which is absolutely essential for perfect timing, 21.4772 megahertz. All we need to do is go to the original NES here, 21.47727. And that one, I'm assuming is the same, it's just that extra 7 is missing, 4772 something. So from a timing perspective, these should be absolutely the same. Nicely, these are both in sockets here, so that means it's very easy for us to swap them over to the original chips. I'm assuming these gotta be some kind of clones, right? 2A03E, 2A03G, and for the PPU, a 2CO2E, and on my real console here, I have a 2CO2G. So I seem to have a matched set of G chips on this console here. And I think this one comes, look at that. This is a late model, 1989. That's the lockout chip, which obviously this does not have. The original Famicom does not have the lockout chip either. Now, compared to the photos I saw on their website, at least here, they have stuck on some little heat sinks here for these voltage regulators, or this one, and whatever that is, either a diode or a voltage regulator. In fact, is this a bridge rectifier right here? It's a 4-pin package, so that probably is a diode, and this thing can actually accept AC input, so you could potentially use the original power supply from your NES with this as well, but obviously you could see I was just giving this DC, and it was working without a problem. Now, if we look at the back here, you can see the SD card slot. Remember how I thought the STM microcontroller was responsible for that? And I think that's the case because it seems to have traces that run over to the STM microcontroller there. And there's a close-up of the FPGA. Unfamiliar with this particular brand, but I'm assuming this is something that's still or currently in production. There's the STM microcontroller for anyone who's interested in what part number that is. There's the unpopulated header, which we can assume is for programming of the FPGA. Again, the construction quality on this seems absolutely perfect. I have no complaints. Now, as for this multi-IO jack here, the one that I can't currently plug into, we can see these resistors here, which we can assume is RGB and sync. We have a couple of extras, and I wonder if that's for the YC video output. Hopefully it's coming out of this jack, unless it's just somewhere on here that's not exactly populated that we could, I don't know, add a mod or a bodge to gain access to. Here's a confirmation that the right and left audio jack is just mono. So I don't know why they even installed two, probably just for ease of connection to more modern stats with stereo sound. Instead of using a splitter, you could do this. But it's honestly a shame they didn't just install an S-Video jack as opposed to one of these extra RCA jacks, and that would have made the S-Video connection so much easier than hopefully being able to get it off this multi-pin DIN here. Now I'm curious, I have the multimeter out here so we can do some continuity checks. Do we have the audio here found over here on the AV jack? Yes, it is. Okay, so absolutely the audio is routed to this jack as well. We can't see the traces. They're probably on the other side of the board. And here's a close-up of the construction quality. It all looks fine. Not really seeing any issues, no complaints. Now down here on the NES section of the board, all of this I think is pretty much a clone of what we have on the real NES. So besides the CPU and the PPU, these are the two 368s that are on the original NES board. So those match up to these two chips right here. There's the 373, which matches up to this chip right here. There's the LS139, which matches up to this chip right here. And these two chips are SRAM chips, which are 62256, so 8 kilobytes each. And it's going to be the system RAM, or WRAM I think it's called, and the video RAM. And on the original NES, here's the WRAM, and there is the video RAM. And I'm pretty sure these are lower capacity than these two chips, although don't quote me on that, but I'm pretty sure these are 8K each, and I think these are less than that. But it just means that they're just not connecting to the extra address lines, so you can use larger chips, and there's really no problem. And the only other chip on the new one is the HC04, which matches up exactly to this chip right here. There it is, HC04. So as you can see, the actual NES or Famicom portion of this replica board is exactly the same as a real NES or Famicom. There's no actual difference. So that means the timing and the functionality and the compatibility should all be identical. They're even using HC parts here and LS parts there that they are on the original NES, and that should basically bring 100% ultimate compatibility between these two systems. Now I remember looking around at some point at a website that outlined all the variants of the PPU and the CPU, and that can probably help us here try to figure out what's going on this board here and if these are actual clones or what. So we know on the genuine article here that I desoldered the chips, we have G variant. Writes to OEM address causes corruption in the OEM. Leaving OEM address at a value of 8 or greater causes OEM corruption when rendering starts. Particularly susceptible to reflections causing OEM corruption fixed by putting series resistors between the CPU and the cartridge ROM. It looks like the E variant, which supposedly is in the clone console here, was produced from 85 through 86. And looking at the photo of this chip here, in this guide at least, it really looks very similar to this chip here. I don't think this is actually a fake chip. Usually if it's been sanded down and remarked, you wouldn't have these little dimple holes here where it's not textured, and that completely matches what we see right here in the photograph. Now know that if you wanted to convert this console to PAL, it would be possible. You just need to install the correct PAL CPU and PPU into it and change the crystal oscillator. I think that's all that's necessary, although I have no idea if the FPGA can handle the different timing, and it probably can't, to be honest. Now here are some of the unofficial versions of the PPU. As I mentioned, they are branded UMC or have other types of markings on them. Some of them look like this here as well. And I was honestly fully expecting to get one of these in this and not one of the originals. All right, just like the PPU are CPU variants as well. And we know we have the G version inside my actual genuine NES here. And it just says reference model, pin 30 enables CPU test mode. Later runs introduced a DMC DMA bug. And then here's the E version, which I think it's what's in this one. This one here looks more like the way the chip on here looks. RP2A03E, and then 5K526, and there it is, RP2A03E 5L5F3. Again, it's got like the little dimples there. It doesn't look like it's been sanded down. Has this been remarked? I suppose for us to know for sure, let's get the acetone out and let's see if these markings come off at all. Because when it's been repainted, acetone just completely removes the paint. And that seems to do absolutely nothing to that chip, the CPU, and the PPU. I mean, that seems the same. I'm gonna have to say that these seem to be the genuine article, which really is shocking to me. So back on their website, we have a couple files we can download. We have a palettes.zip, which maybe is what goes on the SD card. And then we have some firmware as well. So opening the palettes here, just a directory called palettes, and there's a whole bunch. Wow. Okay, so they're .pal files, and opening one of the files, they just look like this. Does anyone recognize this format? I'm assuming this is taken from an emulator. And let's look at the firmware file that I downloaded. Maybe there's documentation on how to update it. All right, we have a couple files on here. Lava RSC 170-ish K, and these two text files, which we're gonna have to run through Google Translate. All right, so translating the first file. Updated content. Fixed bug that select plus A reset machine does not work for some cartridges. Select A? So on the controller itself, there's a way to reboot the whole console? 1.4 added a prompt in the upper right corner for the color palette display so you don't have to be in the dark anymore. I guess, so it tells you which palette's being used. I think that's what that means. And an anti-shake function was disabled before as it was enabled in this version. Maybe that has to do with like jitter or interlacing or something. Version 1.3 added a palette switching from the controller. Press and hold select and wait 3 seconds, then press the up on the controller to change color palettes. And enable controller reset, press and hold select for 3 seconds and then press the A key, and I guess it reboots the console. So if you're away from the console, you can actually reboot it that way. And it avoids conflicts with the 8-bit DOE wireless controllers. 1.2 optimizes the logic of the EEPROM and replaces the use of the LUT, or the lookup table, I guess, for the palette somehow. 1.1 optimizes the card ejector button processing logic, and the color palette switching is smoother. Enables to handle combination key switches to switch color palette. Press select plus start for 3 seconds and then press the up switch. So I wonder if they've changed it because it looked like you had to hold those for 3 seconds originally. And there's the initial version 1.0. I mean, look, it's pretty recent, July 31st. This thing hasn't been out that long. No wonder why there aren't any videos about it. All right, and then here's the other file that's in here, and I'm hoping this talks about how to do the firmware update. So here we go. Yep, steps. Rename firmware file to be updated to lava rsc.aja and copy it to the root directory of the microSD. Turn off the lava and remove the game card. The game card does not need to be inserted during the update process. Insert the transflash card into the slot. After booting, the system will automatically start the upgrade program and the indicator light on the card slot will begin flashing. Wait 3 to 5 minutes. After the upgrade is successful, the indicator light stays on, I guess solid. If it fails, the indicator light does not flash or stay on. If the upgrade fails, the machine may become a brick temporarily. Don't be afraid. Shut down, restart, and it will enter the flashing state again until it succeeds. Interesting, it becomes a brick temporarily. If upgrade is successful, shut down, remove the SD card, and you can play normally. Be sure to remove the SD card after the upgrade is successful, otherwise it will enter flashing state again. So we can have the palettes on the SD card, but we don't want to have the firmware file on there, otherwise it's going to keep doing the update every time I turn the console on. So that's really it. I mean, there's certainly no other documentation on here. Let's just convert this stuff here. Let's see what this says. Yeah, it supports RGBS. This is kind of what we knew. 24-bit RGB 888, full color output, accurate colors, clear image quality, hundreds of color palettes, supports customized color palettes, firmware upgrades via SD card. Cartridge compatibility is very good, and it can achieve the same compatibility as the original red and white machine. The handle switches the color palette, and the original card ejector switches the color palette with one click. And handle resets the cartridge function. Okay, yeah, it's talking about the reset and the color switching from the controller and the button on the console switching the color palette. And that's all you can really do. It doesn't seem to have any extra features. All right, I wanted to check out what the pinout was on the Genesis. So this is the original version that I have, and it does not have S-Video. This has RGB sync, 5 volts, audio, mono, and composite video. To get stereo audio out of the Genesis, you have to use, well, at least this version, you have to use the headphone jack that is on the front for, regular 3.5 millimeter headphones. And then this appears to be the later version, which also does not have S-Video on it, this DIN connector here. But here is the thing that's interesting. The picture shows it having 3, 4, and 2 pins on the original Genesis. This has got 3, 4, and 3. So that means that the jack on this console is a 10 pin, and the one on the Genesis is a 9. And I just did a quick search for Mini DIN 10. There it is. So a little extension cord here with the right connector on it. And that is something I definitely do not have in the house. I have to say I'm kind of perplexed that it doesn't mention this anywhere about this difference in the pinout, and it didn't even include the cable. It could have at least included the cable, or even just the connector, like the bare DIN jack. I could have soldered my own, but I didn't really think about it, and now we're kind of stuck. Gotta say here, back on the listing, it's kind of a confusing one too. It's actually talking about S-Video. So it has the DIN, and then it has 2 DINs coming out, and they're both the version with all 10 pins. So I don't know what this is doing exactly. And I did a quick search for the Genesis AV connector, and it definitely looks like it's only a 9 pin. Just for fun, I did a Google for 10 pin DIN S-Video cable, but this came up, but I don't see what this does other than composite video and stereo. It says this is suitable for DirecTV receivers. Whoa, so is this where that standard comes from? Satellite receiver that somehow is all on one? Let's do a quick search for that. Maybe we can find the pinout. All right, here's a picture of one of those receivers, and yeah, look, there's that 10 pin jack right there. I haven't immediately found the pinout, but looking around here, there are RGB cables with stereo audio, or I'm not sure if it's actually RGB because it's North America, so it's probably component output, YUV. I'm looking through the manual for the receiver as well. There's no information whatsoever. Only thing it says here in the back is that jack number 2 on the lower receiver is AV out. Some newer models have a 10 pin that support both audio and video. Receivers supporting AV out come with an AV out cable for component video and RCA audio. The AV out cable for composite video and RCA output can be purchased separately. So it doesn't even mention S-Video, it just talks about component. There is no S-Video jack at all on these things. This version here has the component output on it. My assumption is the component output is RGB on this. If I use that same cable, the DirecTV cable that is. So I think the thing to do now is to power this thing up with a cartridge in there, and let's look at the output that's coming out of this thing and see exactly what we see. What kind of signals do we see? So before we do any scoping, I decided to just kind of look at how this video output circuitry works. You see these 6 resistors right here. This has to do with video signals that are going to be going out this multi-AV connector. And I have a feeling the audio and the video actually just come from the same signals that are going through these resistors right here. Now those signals on these traces here make their way through this chip right here, which is a TI TJS 7368, which happens to be a 6-channel video amplifier with various gain settings to do with HD video and stuff like that. And as you can see, there are these passives on the board right here, and these make their way into this chip, and this chip happens to be a BH7240AKV, which is an NTSC and PAL video encoder. So essentially what this does is it takes the RGB bit data, so not just pure analog RGB, but digital RGB with various bits into this chip, and this outputs not only composite video, but also YC or S-Video, and also analog RGB. And all of that makes its way to that chip and through these little resistors here. So I'm positive what we're looking at here is RGB, we have YC, and composite video. So those are all of the 6 video signals that come from this video encoder chip, which incidentally supports PAL and NTSC. I don't know if there's an external clock on here somewhere, but you could switch this into PAL mode, and theoretically this would encode PAL color. While this thing is running at NTSC mode, you would obviously be getting PAL 60, so 60 Hertz PAL. But I'm not sure if there's a color carrier frequency input into this chip. I'm sure there is somewhere on here, and could be coming from the FPGA for all we know. So that's 6 of the signals accounted for, and I took a look on the pinout of this, and I was able to find the audio. So 2 of the pins are audio, and 1 of them is a composite video. So that's 7 pins accounted for. And that leaves us 3 additional pins on here that we don't know what they do. My assumption is that we have a sync signal available on one of those pins, and it doesn't come through this amplifier stage. It's probably coming through some of this stuff directly from the FPGA. And then that's 8. and then maybe we have like 5 volts, something like that, for a SCART cable, and then maybe we have a ground signal. Although the ground could be coming from the shield ground, for all I know on this. So that gives us some insight into what we're looking for on the pins on this connector here. And I need to just plug a cartridge into this, maybe with the test signal generator, and then we can just scope around, look for those signals. So before I do any further investigation on this, I want to update the firmware on it, make sure that goes smoothly, and make sure the palette switching stuff is working. And I want to test out the features using the controller, make sure we can reset the console and switch palettes from that as well. So to do that, I grabbed an SD card, and it was formatted for a Raspberry Pi or something like that. So I need to clean this before I format it as like a FAT32 partition. So I'm just in disk part here in Windows, and I just type clean after I selected that particular SD card, which is disk 3 here. And here we are in Disk Manager, and we should be able to see this now. We do. So we do new simple volume, right click. It's a 16 gig card mounted as the iDrive. We need to definitely do FAT32. It's obviously way too big of an SD card for something like this because it's literally, after the firmware update, is only going to be holding just those palettes. I don't really have any like small capacity SD cards anymore. All I have is these large ones, and it just seems really wasteful. So here's that latest firmware at 1.5. We're just going to copy it onto the Lava SD card here. And I think it said to make sure it was called that, so that's fine. And with the console here, what I want to do is I have this power cord plugged into my USB power delivery bench supply. I don't fully trust that the battery power one is going to be good enough for this firmware update. So cartridge is out, put in this trans flash card here. I do see an LED, I think that's an LED right there on the board. So let's turn this on, see what happens. Okay, so it said 3 to 5 minutes, and then it would stop flashing, and it stays on when it's done to tell you the firmware update is complete. And I'm just thinking the cool thing about the LED being located there is even if you don't have the clear case, you have to open the lid where the cartridge slot is, and then you can see the LED flashing while it's doing the update. So you don't have to buy the clear case for this. That's a nice little design consideration. And there it is. We have solid light, so I guess that firmware update successfully completed. That was pretty quick and easy. I'll power the thing off, and let me copy the color palettes onto here and remove the firmware update. So copying the palettes over, there's an absolute massive number of them, and I guess I don't know a few things. Do I leave the palette folder as it is on the SD card, or I put them in the root directory? But also, oh, what happened here? It has stopped copying. Is my SD card bad or something? All right, well, let's just copy these onto here. These are the ones from Mr. Hopefully these copy. There we go, it did. We'll pop this card back in. So the select button, which I can't do, I realize, because we don't have the top cover in. Let's try what it said to do here. So we held down select for 3 seconds, I think, and then push the up button. Oh, that works. Okay, so do we have access to those extra modes or extra palettes? No. Okay, so maybe we do need that palette directory. So in the zip file, it was just palettes there in the root directory. So we'll replicate that here by creating a new folder, and I'll name it exactly the same thing. We'll just move these into there. My assumption is if you have too many palettes, it's unworkable. So let's give it a try now and see if we can get those color palettes working. So I can push select and up. No, this doesn't seem to do anything. We're still getting the exact same color palettes we had before. What am I doing wrong exactly? Very strange. That does not work as I would expect. And we know the microcontroller has no trouble reading this card because it did the firmware update. It's that same STM microcontroller. All right, I just copied these few palette files from the root of the palettes folder onto the card. And you know what, just for fun, let's copy a couple other ones. Let's put this consumer one just in the root directory of the card itself. So if we see only the consumer file, then we know that's the one that's working. Or if we see any of these, like, let me get rid of consumer here, since that's in both, then that will tell us if any of these are working. But frustratingly, none of these seem to work. Let's just see if there's anything on here. We got some unsaturated ones, or whatever that's for, RGB source. There are so many in here. I guess I just don't know how this is supposed to work. It was my assumption that we could just drop some of these files on the card and then we would see them when we push that select button, we'd see them cycle through. Well, that doesn't seem to be the case. Unless somehow it needs the button, not the controller, to do the switching. Okay, here we go again. So select, up, PC10, YUV, FCEUX, and TSC. No, none of these that I copied on are visible. Let's plug this button back in, power this on, YUV, same. Seems kind of buggy. I took the card out, no change, put the card in, nothing. So if I push reset, hold down the button on the front, even while reset's held down, so the console's frozen, the button still works for switching the modes. Gotta say, that's kind of disappointing. I was really looking forward to this palette switching thing. Doesn't seem to work. All right, so firmware update complete. Palettes are not working. We can switch to from whatever internal ones are there, but ones on the card don't work, which is one of the big features of this more expensive version. The light version has no way to update the firmware, at least with a card like this, and no external palettes. So I feel like I maybe wasted my money a little bit. But anyhow, I think next up, let's see if we can figure out the lag that this FPGA and all this processing introduces versus the composite output that comes straight out of the PPU. Okay, sorry about the flashing. If you don't like it, you have to look away right now, but we're looking at the lag test from the 240p test suite. So anytime the shape enters the other shape, the screen flashes white, and also we hear a beep. Well, you would hear a beep out of the speaker. So I'm currently triggering the scope off of the audio channel, and I'm looking at the video signal that's coming out of the FPGA. The yellow trace is the audio signal, so that's the actual audio we're hearing. And if we zoom in a little bit, once it triggers again, there you go. You can see that it looks like it's sort of, I don't know, square wave and a sine wave, I think, on top of each other. And the red trace down here is the video signal. Now, each one of these peaks here is that text you see on a black background that's made up of the entire video frame. Every frame has 240 lines. And if we zoom way in here and get the trigger point back in the middle, this is one scan line. So we actually have the color burst, and then we have the writing, the little bit of the writing you see on the screen there with the shape as well. And now when we set it to normal trigger mode, anytime there's a beep out of the speaker, or if we had a speaker hooked up, you would see it triggering. And that's why this is sort of refreshing here. Now, if I put the other probe on the video signal that's coming out of the FPGA itself, we can see that it sort of changes, but when the audio starts, there are a number of scan lines that happen where the screen is not flashing white until it actually starts to flash white, which is right here. So that's where it's white. And if we scroll to the end, we can see that the video signal actually stops first, goes back down to black, and then the audio stops. I don't know how perfectly coincided the audio and video outputs are on this particular cartridge. I have a feeling, well, we can see the audio starts first, and we can see that it also ends after the frame. But what we can definitely see here is that the audio definitely is coinciding with the frame being high. So that means that if there's any delay at all, we're talking just scan lines, not an entire frame, not even half a frame, barely anything at all. Here's what's funny. The PPU that's in here now is the G version from my other NES, because the one that was in here wasn't quite acting normal. Pin 21 is the video output signal, the composite video. It's that signal right there that I'm clipped onto. We're seeing what looks like a normal video signal. We have a composite video and then just black, could be in between one of the scan lines. And if we let this run for a bit, the odd thing is I don't really see normal video output on here. Most of the time it's just all black, and occasionally there's just a little bit of information. And if I put the other probe on the FPGA output, which is this one here, you'll notice that I can do single shots here, is that there's like more information coming out of the other one. We have the same color burst, and it's all very much lined up. There is a slight offset. You see that? So the yellow trace is the PPU itself, and the red trace is actually what's coming out of the FPGA. And if we turn on the cursors here, we can actually figure out the exact delay between these two. We have a delta of 153 nanoseconds between the outputs of these two things. And it's pretty much consistent. If we keep refreshing here, there we go, let's move this a little bit there. So 142 nanoseconds. Oh, we're talking very, very little. The issue is, it's really hard for me to know if there's a scan line delay or not. And that's because I just don't really see the same information coming out of the FPGA, which is the red trace, versus the PPU itself. And I don't know why. And what I did is I triggered on the audio, just like I was doing before when we were looking at the output of the FPGA and we saw it going all white. And when I was doing that, I did not see it going white ever. So I had the time base so slow that I would actually catch multiple of the flashes in the entire capture. And I would see the audio pulse again, and I would never see anything coming out of the PPU. So it kind of feels like the PPU is disabled, I guess. I don't know. What we can see is there seems to be correlation between this low down pulse right here, which I assume is, I don't know, maybe like vertical blank or something, on both the FPGA output and what's coming out of the PPU. So notice how there's no more color bursts anymore for these multiple scan lines, and then it resumes right there. So we have color burst, color burst, color burst, color burst. So it all coincides. I think it kind of tells us that we're looking at some kind of video signal out of the PPU, but it's like mostly just black or very little information on it for whatever reason. But it definitely seems like the vertical blanking intervals coincide exactly between the two of them. So I think that delay that I measured before at 145 nanoseconds is accurate. And it's not actually even a scan line's worth of delay. So if you're trying to use this replicated console for speed running and stuff, I don't know if people are going to have a problem with it because it's not original hardware. But the CPU and the PPU and the clock generator and the hardware down in this part of the NES are original. And it seems like the amount of lag introduced by the FPGA conversion of the video into composite or RGB or S-Video, whatever you're going to use on it, is almost nothing. I think we can pretty much confirm that the PPU and the FPGA's video output are very much synchronized and with that extremely minimal delay introduced by the conversion process. That's frankly more than you could have ever hoped for. If you hook up this thing to RetroTink, there is more of a delay on the RetroTink in the conversion process to HDMI than this thing has with its native RGB conversion. Now, when it comes to the AV output, I'm thinking about modifying this board a little bit. We know the audio output here has 2 jacks, but it's really just mono. And there's also a 3.5 millimeter stereo jack here, which is just the audio all over again. So here's what I'm thinking of doing. The positive trace that goes to these 2 audio jacks there's a trace that's just visible right here. I'm thinking of cutting the trace on both sides of this middle jack and then figuring out which is the YC or the Luma Chroma signal coming out of the AV jack and just adding little bodge wires that run over to these jacks. So these will become the Luma Chroma jacks, which is all S-Video is. It's just 2 signals. And then for audio, I'll need to connect a 3.5 millimeter jack to get the sound out of this thing. And I have a little notepad thing up here where I've already figured out a couple of the signals. So the 10-pin DIN, on the bottom of the console, there are 10 pins in 2 rows of 5. The first 5 are closer to the edge of the board when you look at the bottom, left to right, 1 through 5. And then on the second row, same thing, 6 through 10, left through right. I figured out there are 2 pins for audio and 1 pin for composite video. All right, first pin, 5 volts. I figured that's there because that's usually needed for a SCART cable. Pin 2, composite video. Yep, looks like composite video to me. Next pin. Well, we have a video signal, obviously, but is that Luma or one of the RGB signals? Let's look at the next pin over. This one here, that's the chroma signal. So what chroma information looks like on a scope, if you're just looking at chroma, you see a color burst, and then you'll see patterns that are similar to the color burst. So that same 3 point whatever megahertz signal at varying intensities and phase. And that's how the color information is encoded. So that means pin 4 is chroma. When we look at this signal, which is pin 3, it's a little harder to tell if this is an RGB signal or this is actually the Luma information. But I'm actually thinking that is Luma because now I'm on pin 5 and notice we see ramping and stuff, but it doesn't look like a stair step of ramps. It's just sort of a few ramps, but notice there's also no sync information in here. We never see the signal dropping down below. But if I go back to pin 3, you see it dropping down there, and that's sync, horizontal sync signal. So that's pin 3. So pin 3 is definitely a Luma signal. Another way to tell is I have the color bars up, and when we look at these with the Luma signal, we should see a stair step where it gets bright, and then the steps just sort of go down and down and down. And yep. Now, of course, we're also seeing the bottom and the middle scan lines. So not every scan line looks the same. So if we do single shots, I think that's it. This one. So that's the white, yellow, cyan, and green, same intensity. And then the purple or magenta, red, and blue are all similar intensity. And then black. Now, if you were looking at real color bars, it would actually be a proper stair step. But on the NES, there aren't enough luma levels to show the color bars with the stair step that it should be there. Okay, I'm on pin 5, and let's single shot this. So can we tell what color this is? If it's blue, which I think it is, we have a full signal here on the far right, then nothing, which is red, then magenta, where it's full, then nothing, which is green, and then a full signal, or nearly full, for cyan, then nothing for yellow, and then a full signal for white. So pin 5 is definitely blue. Okay, let's go down to the next row, and I'm on pin 6, so the leftmost pin on the second row. This is obviously a sync information, because all we're seeing here are pulses, and it's, well, 3.3 volts peak to peak, and often the sync signals that go into monitors is 5 volt peak to peak, but 3 volts works as well, or 3.3 volts. So pin 6 definitely is composite sync. All right, we are on pin 7, and I'm gonna say that this is probably red. And the reason why I say that is because the blue, which has a little bit of red in it, is very low, then full red, then full magenta, and then we have green, which shouldn't really have red in it, but it has a little bit mixed in there. So that's obviously has a little bit there. Then cyan has none, yellow has full, and white has full. So pin 7 is red. And then moving on, I already know that pin 8 is audio because I traced it to the 2 audio jacks that are there. So we don't need to check that. So we have the white, the yellow, the cyan, and the green all have full green. And then you basically have very little green for the magenta, red, and blue. And then there's some blanking time, and then it starts again. So, yep, without a doubt, pin 9 is green. Now, what's funny is if you take a look at this, there's no ground pin on any of these pins. So this 10-pin DIN is maxed out, and it obviously uses the shield, like the surround part of the connector on the DIN, as ground. So if you make your own cable, you have to make sure you solder a ground wire onto the shield part inside the little rubber boot there. Otherwise, you're not going to have a working signal. So video plus audio ground is the shield. So now we know what all the signals are on here. I want to run Luma Chroma to this where I don't need to use a DIN cable, because obviously I can buy one of those DirecTV cables and get the RGB working on here, but there's no easy way to get that whole S-Video thing working. So I'm just going to make it where these audio jacks are the S-Video all the time. So I'm going to cut that trace, and then I can just run bodge wires over between the DIN and these 2 jacks. And I'll have to check to see if the audio on the 3.5 millimeter here is still connected once I cut these traces. I have a feeling it probably goes from here over to there. So I'll just need to run a bodge wire from this over to the appropriate jack on here for the audio, which you can see right there. It's those 2 jacks. You can actually see that trace making its way. So I just use this little engraving tool here. This is my tool of choice to do these modifications. And I'm just going to do it right here in the middle. And it's obviously very easy to repair. I could just put a little metal bodge wire if I want to restore this back to the way it was. So it's always hard to tell with that black solder resist if I've actually cut through properly. So nothing that the multimeter can't figure out. So let's see. There we go. We are cut there. And let's see to here. Yep, we're good. And these are definitely cut. So I have a feeling these are connected to this. Yes, they are. So because this is ground right here, I'll run the bodge wire along the edge here and then back and pick it up there. And then we'll just do the same thing for the S-Video. And for Luma Chroma, I'm going to put the Luma on the white jack because black and white, and then I'll put Chroma or color on the red jack. It makes the most sense to me, not to mention Luma will be right next to the video jack. There we have it. So this is now the Luma, that is the Chroma, and the audio is just the 3.5 millimeter jack. And I routed the video cables away from the audio, which is just hugs the ground plane right there. Should minimize any kind of audio buzz picked up on the 3.5 millimeter jack. Okay, so audio is connected to 3.5 millimeter now. Video is still on here. Let's just see if the thing is still working fine, just as it is here. First off the bat, I can hear some buzzing now through the audio. And let's just see what's going on exactly here. I think what's happening here is I must not have sufficiently cut the trace between either the chroma and the audio or something. Something's not right here. Oh yeah, this is kind of obvious. There's a trace on the top side of the board, and I didn't cut it. So obviously that pin and that pin is still connected. Well, I can see the trace right there between those jacks. I'm gonna have to try to cut that. I might have to use a knife though. I'm sure as I was powering this up, people were probably screaming at their screen. All right, here we go, try number 2. We should have nice loud audio now too. Oh, well, we would if I plugged the jack in. Yes, yes, that's much better. Nice. Okay. Sounds good too. Sounds really good. Game is working perfectly though. This is exactly how it should work on a real NES, which is awesome. So the way I'm gonna hook S-Video up is using an adapter like this, which I made a long time ago. It has an S-Video jack on one end and the 2 RCAs on the other. And I use this specifically for Commodore 64s and Ataris and stuff like that, because my breakout cables to plug into those just go to 2 RCA cables, because that's exactly what the Commodore 1084 uses, for instance. On here, we're gonna switch the input to S-Video. I think I have the cables backwards. Oh, no, we don't. Ooh, it looks good. Looks really good. So just hitting start will load the last game. I've never seen an NES hooked up through S-Video ever in my life. This is awesome. This means you can plug it into a Commodore 1702, 1084 just through S-Video without even worrying about the whole RGB. Not to mention if you find yourself a large 20, 27-inch TV that doesn't have RGB or component component on it, you can hook that up and have the much, much better looking image. I mean, there's no jail bars. The video quality is great. I have no complaints with this. Oh, wow. I am really impressed. Really impressed. All right, this is Micro Mages. Oh, I'm loving this. I am freaking loving this. It looks so good. I know it's no RGB, but you know what? S-Video is miles ahead of component, of composite, and this looks freaking great. Right, let's try this here, which is a music demo disc. I love the track, some really good tracks on here, really good. Okay, so remember that I am running the PPU from the original NES, and I took the one that was in here out. I don't know if this chip works or not. I only based that off of what I was looking at on the composite video output pin 21 on this. I just didn't see output that looked normal. But even out of this one, we're not really seeing what I would expect. But this one was also looking really weird. And I just don't know if this console drives the chip in a way where it doesn't really output any video. But then it's so strange that obviously it's generating video perfectly. So I don't really know what's happening there. I don't think visually we're going to see any difference between this PPU and this one. And maybe what they were doing is using marginal real OEM PPUs, ones that didn't have good composite video anymore, because it didn't matter anymore. The composite video pin on this doesn't obviously go anywhere, because I'm pretty sure that the FPGA is recreating all of the signals from scratch. All right, well, I'm ready to go grab a CRT and test this thing out with Luma Chroma. I was going to make an RGB cable, but I don't think it's even worth it, because this cheap cable here, I mean, it's just going to be a mess, and it will be something that's very temporary. I'm going to order that DirecTV DIN 10 to component cable. So if you're buying one of these, I recommend buying that DirecTV cable. I can't guarantee that it's going to work because I haven't tested it yet. I'll need to order it. But we know the pinout, and you can validate it by using a multimeter. But I'm assuming they follow the same general pinout, at least with the component signals, as the RGB on this. So I'm going to go upstairs and I'm going to grab the 1702. I'm going to put this thing back in its case. Let's give it a test. Okay, so I was just about to go grab the monitor, and I needed to fix the secondary or the mapper audio on this cartridge I have here, and I'd fixed that. So I'm playing this VRC6, I think that's what that's called. This is a Japanese version of Castlevania 3, and I'm noticing a little glitching, and I think it's coming from the PPU that's in here. See where I'm standing there? I have the game on pause. There's some bricks right above me. There's some, oh, now it's not doing it. There was some glitching on the bricks right above, like right above where I'm standing. There were some pixels that were sort of flickering off and on. Now it's not doing it. It sort of fixed itself. Now, when I was testing for the video signal delay with the oscilloscope, I saw some of those pixels on the test cartridge, on the 240p test suite. They were just sort of on the left edge of things and kind of sparkly almost. And then I switched out to this one, you know, for testing to see the video signal if it looked different. And I never saw those pixels again. And they're not there all the time, and it's not there now, but it was definitely there a second ago. So as I said, I'm really thinking that it's something to do with the PPU that's in here. I think it's maybe marginal, but you know, it looks totally fine now. And the dots were so minor. Oh, there they are, there they are. You could just see them right above my head. See the white line there? It's doing it now. Oh, and it's sort of all over the place below me as well. Yeah, that's it. That's exactly what it was doing. I mean, this could be a problem with the whole FPGA circuit itself. I guess what I need to do is swap out to this other PPU here, see if that problem goes away. Look how bad it looks right now. Oh, I see it over on the left side too. It's kind of all over the place. Weird how it comes and goes, isn't it? I don't think it has anything to do with the audio. Let's see if the music's still working. Yeah, music sounds totally perfect. Incidentally, the problem with the expansion audio was the FPGA here has an audio output that then goes to pin, I think 46 on the cartridge connector here, which gets mixed with the system audio. And they had a 460 ohm resistor between the FPGA and the pin there. And with the oscilloscope, I could see that there was audio coming out of it, but it was very, very quiet coming through the speakers. And there's a couple options in here for like volume of the expansion audio. It didn't really make a difference. It was quiet or more quiet. So I went to an old like DSL router here and found a little tiny resistor that was the right size to replace it. And I think I found 175 ohms or something like that. I don't know, I just picked a random value that was just less than the 460 and I put it on. Now it sounds perfect. Taking apart these Famicom cartridge shells is really difficult. Even though this one has a screw on it, there are 4 tabs around the outside and really hard to get off. And there's a battery here, so this thing's gonna eventually need to be replaced. Push it back together here. As annoying as it's gonna be to take apart again in the future. Wow, yeah, that really makes a loud snap noise, but it's a really tight cartridge now. Okay, with that done, I think what I'm gonna do is I'm gonna open the Famicom again and I'm gonna switch out both the CPU and the PPU from my good console because frankly, I don't know, I don't really trust these marginal ones. And then I'll play some more Castlevania again. We'll see if the glitching comes back. Okay, so we're back. I've replaced the CPU and the PPU from the other one. Console's obviously working fine. So I'll get back to where I was and I'll keep my eyes peeled for any kind of possible glitching. Okay, we're back where we were before. And yep, I mean, I haven't seen a single glitch. And I was also noticing glitches above the candles, like where the little flames are, and that's not there anymore either. Weird. I mean, marginal PPU is all I'm thinking there, and the one that I took out of that other parts machine is clearly better. As far as the CPU, I don't really know. I just changed it for fun, basically. Obviously, maybe that would make a good second channel video for me to stick the PPU into a real NES and then see if it's working from a composite video output. That would be very curious if they indeed put a marginal part in this. So yeah, if you'd like to see more further testing of the potentially sketchy PPU, I could put it and that CPU into that other NES board and boot that thing up, and we can run it through its paces as well and see if that's working. That would make good second channel video. How exactly do I get that candle up there? I don't know. I see no jail bars or anything like that. It looks really, really crisp. The RGB to HDMI kind of makes everything look a little fuzzy, so to speak. And actually, oh, I hate these Medusa head things. I was gonna say, I hit pause there. There's a little bit of fuzziness where the orange block transitions into the gray. So if you look just to the left of where I'm standing, you have those orange blocks there. The chroma information is bleeding over a little bit. And that is that chroma low resolution thing I was talking about. And with RGB, that would not be visible at all. Now on a real CRT, you don't really notice that nearly as much because we're not looking at like pixel perfect HDMI upconverted video. But on here, yeah, I think RGB would have cleared that up and you'd have a much sharper delineation between that, you know, light orange, dark orange, white line, and then the gray. It would be nice and sharp. Anyhow, if you have been watching me play, now that I've switched out the PPU and you see anything sketchy, please let me know, because I certainly don't see any kind of dots at this point. Oh, I don't want that. I much prefer the potion. Well, okay, now I think it's time for me to go grab the monitor so I can see this inglorious S-Video on a CRT. Yes. All right, well, the monitor's out. I've got some speakers hooked up, and I've actually been playing for a few hours now, and there are no issues. I haven't seen a single problem with anything. Everything works. Now, I think one of the questions that people are probably going to ask is, does the zapper work with this whole situation? Because obviously we have the conversion going on, which we measured that the latency was in the nanosecond range. And I can confirm that yes, it does. So let's use this zapper test program here, which allows you to actually select what you're going to run by just using the zapper gun here. So let's use this music one here. And you just simply move the zapper up and down. And if you move it off the CRT, then you don't have any music at all. And it works from far back as well. Oh, I'm out of frame there. So obviously it's working perfectly. From even far back, I can perfectly select the scan line even. And if it weren't for basically no latency, there's no way this would work properly. No way at all. And let's run Duck Hunt here. Don't need the music so loud because we've all heard that about a billion times. Let's see if I can do this here. Oh yeah, I mean, it totally works. No issues whatsoever. That was bad shooting on my point. There we go. Oh yeah, I mean, I'm looking through the sight on here and it absolutely is hitting those ducks. So the zapper completely works, and there's nothing to say that it wouldn't work through the RGB conversion as well, since the path that the entire thing works on is exactly the same. Fire up Castlevania 3, here's the music. Basically, it's working absolutely flawlessly. Throughout the entire number of hours I've been playing this, no sparkles, no dots, nothing. It has been absolutely flawless in every single way. And it's really quite cool to play through the S-Video connection. And like I said, the RGB would be that much sharper, although this monitor does not have the RGB. This is actually my modified Chinese monitor here, so we can bring up the menu and stuff like that. But it does have S-Video in it, just like the original 1702, and it looks freaking fantastic. None of the weird dot crawl that you get with regular NTSC, and it's so weird playing NES games without any of the dots, because I'm just so used to seeing the dots, and none of them are there. And what's just really cool is because it's running the original CPU and the original PPU, compatibility is 100%. I mean, of course it's gonna be, right? It is really just a clone of the NES with the original chips. And then, yeah, it looks freaking great. A little bit of glitching here is totally normal. That's what you always see on Super Mario Bros. 3. It's just the way the mapper works here. And I kind of love the selectable color palettes. I wish I could get them working with what's on the SD card there, but you know what? This one here, this FCXU one, is frankly totally fine. I'm not complaining about it whatsoever. Okay, so that's gonna be it for this video. I am mega impressed with this clone. I mean, I don't know if we can call it a clone, really, because the main part of the NES is literally exactly the same as the real thing. And now that I put a known good PPU and CPU in it, well, that got rid of that little weird sparkling issue we were having. And now this thing is 100% as good as any other NES, but in fact it's better. Because the Famicom I have here has a lot of jail bars due to the PCB design, I think, and the NES itself does fine. But then this does S-Video and RGB. Like, how cool is that? I guess my only two gripes are I'd really like to get the palette switching working. Maybe I need to try a different SD card, a smaller one. Although I used that exact card to do the firmware update and that worked. So why doesn't the palette switching work? The build quality of the clone itself is really good. The case is nice. It's small, it's compact. Yeah, it's awesome. Now, since the palette switching doesn't work, I'm not sure spending the extra $30 on the version I got is worth it versus the light version, which doesn't have the SD slot, nor does it have customizable palettes or firmware updates for the RGB engine. But really, it seems like the only thing the firmware update could change is the functionality for like resetting the console from the controller. And if you don't care about that, then who cares? And the built-in 4 palettes or whatever that's in there seem good enough because this FC-EUX one is pretty nice. I think over RGB it would look really good. There isn't much else for me to say. This is probably going to be my NES that I'm going to go to and use forever because I really like the whole S-Video nature of it. And I keep this monitor up in my office because the one I usually have hooked up to an 8-bit computer or whatnot. But it's easy enough to just plug in the NES into the back of it and then there we go, S-Video, and it looks really, really good. I suppose the only bad thing is if you're in North America or in Europe and your game collection is all front loader type cartridges, they're not going to work on this Famicom, but I'm pretty sure that you can buy a little adapter that just plugs into the Famicom and then it allows you to use the larger cartridges and just sticks out a little bit further. The fact that it uses regular NES controllers and NES zappers and stuff like that means that, well, compatibility with all your existing peripherals, no problem, like the wireless ones and stuff like that. And it still has that 15-pin connector on the side, so you can still use the Famicom computer, keyboard for basic and stuff like that, and any of those other peripherals that were designed for the Japanese market that plug into the side of the original Famicom. So it's kind of like a win-win situation other than the cartridge compatibility. So as I mentioned earlier in the video, if you want me to test out this potentially dot-ridden PPU in a standard NES through composite video, let me know. And I will definitely be ordering the RGB cable from AliExpress. It's going to take several days to get here. So when I do that, maybe I'll do a combo video on the second channel where I test out the PPU here and then also test out the RGB on this console just to make sure that it looks good. But looking at the circuitry and the way it's designed, I have no reason to believe it's not going to be sharp and look really nice. And we'll have even more color clarity than, of course, the S-Video does. And that already looks really good. Totally happy with that. And I'm a nitpicker for the way things look on CRTs, and this looks really good. So I think that's going to be it. I'll put the links to where I bought this and the other stuff down below, so if you want to check it out for yourself, you can. Thumbs up if you like this video, subscribe if you haven't already. Huge thanks to my supporters. Their names are scrolling up the side of the screen. I think this side over here. They make it possible to do this full time. You can become a supporter. There's a link in the description below for both YouTube membership and then also Patreon. It's up to you. It's kind of the same on both. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.